I'm saying that this is a path covered by an object. Okay, this is a path covered by an object. The object starts from position O and then covers a distance while choosing this path. Okay, and then move to this path and then reaches to this position D. Okay, so please tell me, if this distance from here to here, if this distance is 7 meter, okay, then what will be the distance and displacement covered by that object or that vehicle or that substance? Try it. Are you trying? Huma, Sarah? Sorry, what is?
Yes.
Okay. Oh, sorry for that. Hope you done. Are you getting some problem, beta? Are you getting some problem?
No, sir.
Okay, tell me, what is the distance and displacement?
Sir, a perimeter of a circle is 2 pi r, but it's half a circle, that's semicircle, so we divide it by 2. On multiplying 2 times 3.14 times 3.5, you get 21.98, and then you divide it by 2 because it's half, so you get 10.9. That's like the distance that you cover. That's 10.9 meters.
Distance is 10.9 meter. Okay.
And displacement is 7 meters.
Displacement is 7 meter.
No,
Okay.
it's 14, sorry.
Okay, it's 14 meter. Okay. Displacement is 14 meter. Is 14 meter. Is this correct? So who was saying this one? Sarah?
Yes, sir, I was speaking.
Sarah is speaking. Okay. Yes, tell me, Veer, beta, is Sarah is correct? Veer, tell me, beta, is Sarah is correct? Veer, are you there in the class? Huma? Huma, are you there in the class? Huma? Hello?
Yes, sir.
Yes, beta, I'm asking, is Sarah is correct or not?
Yes.
Sarah is correct. Okay. Veer, please tell me. Veer, is I'm audible to you? Veer is not listening, I think so. So, okay. So, beta, Sarah, you have to keep in mind one thing here, that never a distance can be shorter than a displacement. Okay. Means here distance is 10.9 meter, which is shorter than displacement. Distance can be equal to displacement. It is possible. Okay. Distance can be greater than displacement. it is also possible, but distance is shorter than displacement. Displacement, it is impossible. It is not possible. Okay, beta, it is not possible. Why?
Yes, sir.
Why?
I just took one circle, but the person who was traveling covered two, so 10.9 plus 10.9, so it's 21.8.
21.8 meter. Okay, let me check. So you think that this is simply half circle and this is half circle. So the distance covered by him is simply the circumference of a circle. Okay, so you can write it, the distance is equals to circumference of a circle. If a teacher know the student, this half circle plus half circle will gives you a complete circle. So teacher know this one. So simply you can write this one, that distance traveled will be equal to the circumference of the circle. No, you need to not write two circles, two half circle into two. No need to write this. Be smart, write this one. The distance will be equivalent to the circumference of the circle, and that is equals to 2 into pi into r, and that will be equals to 2 into, that is 22 by 7 is the value for this one, and this is 3.5. The radius of the circle is 3.5, that is the diameter is 7, so it is 3.5. So 3.5, how can I write 3.5? I can write 3.5 as 7 by 2. So you can simply cut this 7 by 7, this will cut 7, you will get here simply 22 meter. Okay, got it, beta? Got it?
Yes.
Okay, now the distance is simply 7 plus 7. Sorry, displacement will be simple. It is 7 plus 7, that will be equivalent to 14 meter. Okay, so I hope you understood. Let's move to the let me differentiate between distance and displacements more clearly to you. Okay, so that there should not be any kind of doubt. Okay, so let's add one more slide. Okay, and here we will start discussing the difference between distance and displacement. A distance vs displacement. Okay, so distance can be simply, first it is a scalar quantity. I'm going to tell you that what is scalar quantity and what is vector quantity. But since I'm discussing here right now, so I'm saying only it is a scalar quantity. It is vector quantity. Okay, next point is it is scalar quantity, it is vector quantity, first of all. Second, it can be positive or zero. It can be positive, but the distance can have a positive value. It can be positive or zero. It can be positive, negative, or zero. It can have all three values. Okay, next is it can be, it can't be, if I'm saying there that it can't be smaller than displacement. It can't be smaller than displacement. It can be smaller than displacement, but can't be greater than distance. It can be smaller than distance. Sorry, we have to write here distance. Okay, got it. So displacement we can write it is the actual path covered, actual path length, and this one is shortest path length, shortest distance between initial and final position, initial and final position, and final position. You got it? You got it, Sara, Veer, and Uma, all of
Yes,
you?
sir.
Okay. Veer, are you there?
Yes, sir.
Veer? Okay. We were discussing we have discussed the questions, and I was asking you that Veer, is Sara is correct, is Homa is correct. So you were not you were not there. I think why were you not
So I was here, but so I don't
replying during the
access
time?
it on.
Okay.
So know the technical thing. So sir,
Oh,
voice wasn't audible in this. So I was
okay.
do it, but
Okay.
after some came. Sir.
Okay. Okay. No problem. No problem. Is my voice is coming clearly to you without any lag, without any problem? Is I'm clearly audible to you? Sara, is I'm clearly audible to you without any lag?
Yes, sir.
Okay. Okay. Let's move. Okay. There is another question. A body travels in a semicircular path of radius 10 meter. Again, solve this question. Try to solve this question. A body travels in a semicircular path of radius 10 meter, starting its motion from point A to point B. Right? I'm going to draw here. Suppose this is a semicircular path, okay? And this is the point A, and this is the point B, okay? Starting from the radius of this one is 10 meter. 10 meter, okay? From A to B, calculate the distance and displacement both. It is the simplest question that I have given you in the previous class also. Because practice, you need to practice again and again. Tell me, try. I'm going to give you 2 minutes. Done?
Yes, sir.
Okay, tell me, what is the distance and displacement?
So the distance is 3.14 meters and displacement is 20
3.14
meters.
meter.
Yeah, considering pi is the value of 3.14. And displacement is 20 meter.
Displacement 20 meter and distance is
Distance is 31.4.
Okay, distance is 31.4. Okay, 31.4. Okay. Let me check. Okay. Veer, what's your answer, beta? What's your answer? Veer, have you done?
Hello.
Yeah, beta. I'm listening to you. Veer, do you have any problem regarding to the internet connection? Veer, I'm listening you. Okay, let me check. That is distance will be simple. This is 22. This will be half pi r. Okay, this will be 2 pi. Sorry, half pi r. That will be this one. Okay, or you can write it 3.14 into 10. That is 31.4. This simple. It is simple that the distance will be if the person reaches from A to B position. Okay, so this will be the half of the circumference. So distance will be equivalent to half of circumference. Okay, and that will be equivalent to 2 pi r divided by 2. So this will be equivalent to simply pi r. Okay, sorry, 2 pi r divided by 2. You can cancel out this one. This will be pi r, and that will be equivalent to 3.14 into 10. That will be 31.4 meter. So this way, this is actually the distance. Okay, and displacement is simply diameter of the circle. Displacement will be equivalent to diameter of circle, and that will be equivalent to 20 meter. Okay, let's move. Here is another question for you. Please solve this one also. I think Veer, are you there, beta?
Hello.
Yeah, beta, I'm listening to you. Your voice is clearly audible. Very good, Sarah. And Huma.
So I have some issues, sir. I don't know why.
What? Repeated, beta?
So your voice is not audible for me. You're audible in
Fractions of second. For fractions of seconds.
yes, sir. And then you're going on mute for me.
You are going mute
Yes.
automatically. Okay, beta, disconnect the class and join it again for the once. Huma, let me confirm to the other students. Otherwise, I have to change my internet connections also. I can change it. Huma and Sarah, is my voice is clearly audible to you, or you are facing
Yes,
any?
sir.
Yes,
Okay.
sir, you're clear.
So if Veer, it is from your end, please disconnect and join it again. Okay, then you will be. I think your problem will be solved. Okay, so try it once. Okay, so this is another questions for you, Huma and Sarah. Please solve this one. First of all, for solving this question, okay, Sarah is raising hand. Yes, Sarah, do you have any doubt?
No, sir, I am done with the question.
Okay, okay. You have done the question.
Yes, sir.
Okay, tell me what is the answer?
So the distance is 8
Okay.
kilometer, and the displacement, it's approximately 5.6.
Okay. Displacement.
Is 5.6
Displacement is
kilometers.
5.6 kilometer and distance is 8 kilometer. Okay. So Sarah, sorry. Okay.
Yes, sir. Am I audible now?
Yeah, beta, you are clearly audible.
Sir, I joined with a different device, so I guess I don't have problems now.
Oh, okay. Very good. You are so intelligent. Very good. Okay, beta. So we have a questions on your screen, Veer, and try to solve this question. And Huma, please, beta, tell me, is Sarah is correct? Have you done this question, or you are facing a problem?
Yes, sir.
You are facing problem.
No, sir.
Have you done?
Yes, sir.
Okay, tell me what is your answer. The same. Sarah is correct.
Yes.
Okay, Sarah is correct. According to Huma, Sarah is correct. Okay, let me solve this one for you. It is simply, we have to solve this one by using, okay, we tell me which method we will use to find this length. This is a distance, this is a displacement, okay, between the initial and the final positions. Which method or which formula or which theorem will help us to find this distance? Do anyone know the answer?
So Pythagorean theorem.
Very good, Pythagorean theorem. Very good. So it is simply, if we have to find out the distance, so we will have this one is the hypotenuse. So displacement square will be equivalent to 4 square, or you can write it like this way, OB square will be equivalent to AO square plus AB square. Okay, now you can write here, OB, you have to find out the square of OB square is equals to 4 square plus 4 square, and that will be equivalent to 16 plus 16, that will be equivalent to 32. Okay, OB square is 32, then OB will be equivalent to under root of 32, and that will be equivalent to approximately 5 point something. Okay, so 5.65 will be the answer for this kilometer. Okay, very good, Sarah, you have done an excellent manner. Okay, so do you understood this? Do you understood?
Yes, sir.
Okay, let's move further. Okay, let's talk about the scalar and vector quantity now. What is the difference between the scalar and vector quantity There are the different types of physical quantities that we usually study. Okay. Physical quantities are what are physical quantities? Those quantities that help us in the measurements. For example, if we are just going to measure some length, so meter will be the physical quantity. We will consider it as a meter distance is a physical quantity. Okay, so there are some physical quantities that we are just going to discuss here. There are scalar quantity and the vector quantity. What is a scalar quantity? Those quantities, those physical quantities that has that has only magnitude. Okay, only magnitude. Okay, and what is vector quantity? Those physical quantity that has both magnitude as well as direction. Okay, we call them vector quantity. Okay, for example, just imagine, Sarah, if I'm thinking, if I ask you, Huma is going to tell me the answer. Okay, Huma, if you think, what is the temperature of your room right now? Huma, may I know the temperature of your room? Approximately, what will be the temperature of your room right now? Yeah, tell me, Huma, what is the temperature of your room right now, beta? Approximately
24.
what? 24 degrees Celsius. Okay. Okay. Is the temperature of your room is, let's suppose this is Huma room. Okay, Huma's room. Is this temperature is in this direction, upward direction, in this direction, or downward direction? Yeah, this temperature is in all direction. Tell me, do the temperature has a particular direction?
No.
No, you don't think that? We can't say that temperature is on the 24-degree temperature is on the right hand side and 25 degrees temperature is on the upper side and 16 degrees Celsius is at the bottom side. We cannot say this. The temperature is of the whole room. Okay, so this 24 degrees Celsius is the magnitude. This is the magnitude. This is the value, magnitude. Okay, but it is not going to have any specific direction right now. Okay, if you go to the market, okay, and if you buy some bananas, if you buy some apples, let's suppose if you buy some apples, okay, so do the scalar, you know that the scalar, this is the weighing machine, okay, is it possible that the main weighing machine can measure the weight if it is inverted like this one, if the apples are put on the bottom sides and the weighing machine is on the upper side? Is it possible? No, only the spring balance can measure such type of weights, but actually weight is a force. Weight is a force which is acting downward. It always acts downward. Can you measure the apples if you put this weighing machine like this way, like this way, okay, and you put your apples here, okay, if you put your apples here, so will you be able to measure the weight of this apple? No, I think you will not be able to measure the weight of this apple if you put this machine inverted. Okay, so you cannot measure this the weight, since the weight is a force which is always acting downward. It has a particular directions. Okay, so you can measure the weight. So weight is the, if you find this apple at 100 grams, or you can weight this apple 300 grams. Okay, so 300 gram is the magnitude of this, it is the magnitude of this apple, okay, which is weighing, but the weight is a force which is acting downward. It is a force which is acting downward. Okay, so we will consider this one as we'll consider that weight is a vector quantity because it is going to have direction as well as magnitude. Okay, so actually weight is a force which will measures in newtons. Okay, we measure this in newtons, but sometimes you see that you went to the market and you find you find the weight, you went to the market, you find if you are going to buy some apples, will gives you this in grams or kilograms. You are just going to buy these apples or fruits or whatever the things you are going to buy. Okay, so this is measure, but that you measure, that you buy, that is the mass of that substance, or you can say that this is the gram atomic, we can say that weight, that is the weight, but actually that is not measured in the newtons, because we usually make a special unit for, we are not going to every time, we are not going to multiply it by 10. We are not going to say that if I'm 100 kg, if a person is of 100 kg or 70 kg, so we cannot, because we know that the person is already on the ground, so we are not going to calculate its force. What force is, we are not going to multiply it by 9.8, that is the gravitational force, that we will going to discuss in the next chapter. No need to worry, but just simply remind this one, or keep in mind that those quantities that are going to have the both direction as well as magnitude are called the vector quantities, and those quantities that are going to have only magnitude are considered to be as scalar quantity. So give me one examples, each of you, that give one examples of another vector quantity that you are familiar with. Yes, Veer, it's your turn now. Tell me, give me an examples of vector quantity and a scalar quantity. Veer, is am I audible to you?
Yes, sir. So
Okay.
a vector quantity, it moves in a one direction, sir, and
Give me only examples. Example of a vector quantity. Like I have given an example of weight. Weight always act downward, so it has magnitude. If I'm going to find the weight of a person, that is 500 Newton, 300 Newton, so that will be the 500 Newton will be the weight. Okay, weight of a person, and it will always act downward. Okay, so give other examples of a vector quantity that you. Gravity. Okay, gravity, yeah, gravitational force, that is also, or okay, or force can also be a force on of one object can also be a vector quantity, because if you are applying a force, so force, if you are applying, then if you are applying in this direction, the force will act in this direction. If you are applying from upward, it will act, okay, downward. So according to this, the force is going to have the magnitude. If you are applying 10 Newton force, then it will be it will be going to have some directions. Okay, the force is going to have a direction, so it is also a vector quantity. Okay. Oh, okay, Sarah, now it's your turn. Give an example of vector quantity. Sarah, is I'm audible?
Yes, sir.
Okay, give
I
me
guess velocity is an example.
okay, velocity is an example. Velocity is correct. Velocity is an example for we can say that it is a vector quantity because it has a directions as well as magnitude. Okay, so velocity is a vector quantity. Okay, Huma, give me an example of another scalar quantity. Huma, is I'm audible? Huma,
Sir, I didn't understand it.
you didn't understand this? Okay, beta, let me explain you again. No need to worry. Okay, there are some types of physical quantities that we have. Okay, like physical quantity means that help us in the measurements. Okay, like we have mass. Mass is a physical quantity. Okay, velocity tell us how fast an object is going. Okay, we have temperature, that gives us the degree of hotness. Okay, how much hot a something is. Okay, how much cold a something is. The temperature tells us that. Okay, and similarly force tells us how much an force on an object is exerting. Okay, so force is also a physical quantity. Okay, and similarly speed is also a physical quantity. Okay, in the similar way we can say that gravity is also a physical quantity. Okay, a gravitational force you can say. Okay, a gravitational acceleration you can say, that we will going to discuss later about these terms. So okay, these is similarly second, time is also a quantity that tells us about the durations of something. Okay, the times tells us how much durations of an object. Okay, the duration, about the durations, the times tells us. Okay, but some of these quantities like displacement, I'm taking another example, displacement. Okay, distance. Okay, so just talk each of them, about each of them. Okay, this is mass tells us how much a heavy an object is heavier. Okay, how much an object is heavy, or how much. So mass is simple. Mass tells us, means it is a simple mass is an we can say that it is an intrinsic property of every matter. So every matter, how much we can say that how much heavier an object is, it is told by the mass. Okay, so mass is an intrinsic property of every matter. Yeah, we can say that it is a mass is a property of an object, of a matter, that resists any change in its directions, or we can say that that resists any change in its directions, in its motion, in its, so it is an intrinsic property. So mass is measured in kg. Okay, similarly velocity tells us how fast an object is. Okay, how fast, if an object is running with a speed of 5 meter per second. Okay, 5 meter per second, another object is running with a speed of 10 meter per second, another object is running with a speed of 15 meter per second. So it tells us how fast an object is. But there is one thing, when an object is traveling, if I'm saying an object is traveling with a speed of 5 meter per second. Okay, so it is going to have some directions. Velocity and the speed are going to have, means only two difference. There is only single difference, that the velocity has magnitude as well as directions. So if I'm saying that an object is moving with a speed of 15 meters per second in the direction east, okay, or 10 meters per second in west. So it is simply, we can say that object has this velocity. This is velocity. But if a car is moving like this, okay, so this is 10 meters per second. If an object is traveling with a speed of 10 meters per second, so it is not going to have any specified direction. Similarly, about the temperature, talk about the temperature. Temperature, you knows very well, it will simply clears you that if we go in a room and there is a temperature of 15 degrees Celsius, 15 degrees Celsius, and the room we goes to, that is temperature is 35 degrees Celsius. So we can say that this one is colder and this one is hotter. Okay, so it tells us how a degree of hotness. The degree of hotness is given by the temperature, but it is simple that you must understood that temperature do not have any specified direction. Can you say that a temperature on an object, if a room is going to have 15 degrees Celsius, so the temperature is going to have, yeah, we can say that a temperature will be exerted in all directions. You cannot say that the temperature is going to exert in the west or upside or downside. It is not going to have any direction. So this quantity will be considered as scalar quantity. Okay, now let's talk about the force. Can you exert a force on an object in unspecified direction? If I'm saying you, this is a box, Huma, just understood beta, this is a box. Okay, if I'm saying exert a 10 Newton force on it, so you will ask me, you will simply ask, sir, should I exert the force from the upside or from the side, left side, or from the right hand sides? Okay, so this is that you cannot exert. If you are exerting the force in this direction, the force will not be exerted on this direction. Okay, so it is simple that the force is going to have a direction. Force is going to have a direction. If you exert a force on the wall that is in front of you, then the wall that is on the left hand side, right hand side, and backward from you, that will not get that wall are not going to get that force. Okay, so it is simple that if you are exerting a force on an object, the force must be in a specified direction. Okay, so is it simple? Is it clear to you that force is always exerted with a magnitude and a directions? Okay, so force has a magnitude, like it is 15 Newton, it is 10 Newton, it is 2 Newton or 20 Newton, but it must also have some direction. A force must also have some direction. We cannot exert a force in all direction. A force is always exerted in a specified direction. Okay, so is it clear to you now? If I'm talking about the time, if it is 10 a.m., yeah, if a body moves from A position to B position in 10 seconds, so can you say that 10 seconds is on the right hand side or the upside or the downside, or we can say that it is in the east or on the west? No, time do not have any direction. Time do not have any direction. It is directionless quantity. So do you understand that this is a directionless quantity? Now talking about the displacement. Displacement, if I'm saying an object is traveling 15 meter, so it must have a direction. For example, if an object travel from from 0, O, and then reaches to the point A, and then reaches to point A, and then reaches to point B. Okay, so now I'm saying here, what is the displacement of an object? So you must have this one. Okay, you must draw a line and you can clearly find out the direction of this one. If suppose this is, we can write it like this way: east, west, north, south. Okay, if an object travel to this direction, let me give you, this is north and this is east. So first it travel to 15 meter north and then 15 meter east. Okay, 15 meter east. So you can find out its displacement directions, and that will be the northeast direction. You can say the object is in the northeast direction. So displacement is going to have both magnitude as well as direction. So displacement is going to have both magnitude as well as direction. So, but distance is not going to have any direction. Distance do not have any direction. So now, is it clear to you, Huma? Huma?
Yes, sir.
Is it clear to you now that Some physical
Yeah.
quantities have direction and some do not have direction. So those have direction and that has only magnitude but no specified direction, that are called the scalar quantities. Do you understood this one?
Yes, sir.
Okay. Is I'm clearly audible to you, all of you, or my voice is lagging? Yes.
Sir, your
We,
voice keeps lagging.
oh, my voice is lagging. Let me change my internet connection. Wait a minute. Wait a second, okay? So Huma is it is clear to you now?
Yes, sir.
And Veer, is it clear to you?
Yes, sir.
And Sarah, is it clear what is scalar quantity, what is vector quantity?
Yes, sir.
Okay, let me change my internet connection first, then we will be going to start. Okay. It's not a free Wi-Fi actually. I named this Wi-Fi as free Wi-Fi. So wait a minute as it is being connected. So is I'm audible to you now clearly? Huma and Sarah, is I'm audible to you clearly now? Hello.
Yes, sir.
Yes, sir, you're audible.
Okay. But there is one problem. I'm saying to you that any quantity, any physical quantity that is going to have, we can say that direction as well as magnitude. Okay. So that is a vector quantity according to, I'm just telling you, but current also has the direction, but it is not a scalar quantity. Current has direction. Current has direction as well as magnitude, but it is not a vector quantity. Current is simply the rate of flow of charge, or we can say that how much charge per second is flowing in a conductor. Okay, so current is simply, so current always flows from the direction, the specified direction of current is from positive terminal to the negative terminal. Means current flows in the direction positive terminal to the negative terminal. Okay, so this is the direction, and always we can say that the if a current or if 1 ampere current is flowing through this bulb, or 2 ampere or 3 ampere. So ampere means the magnitude. Okay, so 1, 2 and 3 are the magnitude, and the direction of the current is from positive terminal to negative terminal. So why it is not a scalar, it is not a vector quantity, it is a scalar quantity? Why? Can you tell me? Can anybody? Is I'm audible to you? Hello? Sarah, Veer,
Yes, sir.
is I'm audible clearly? Huma, is I'm audible?
Yes, sir.
Okay. So Huma, Sarah and Veer, just listen to me. It is very important right now. Okay, just listen to me. What I want to say, just listen to me. Actually, if I'm saying the quantities that are going to have direction as well as magnitude, it is a scalar quantity. Sorry, it is a vector quantity. It is correct, but there is one point also that we have to add one point also. Okay, just suppose if an object, this is an object, okay, and a person is exerting a is pulling this object with a 5 Newton force, okay, from this direction, and another person is exerting the same force in the opposite direction. Will this object move? Will this object move?
No.
No, the object will not move. Okay, the object will not move. Dear student, that is I need to mention one thing again. If you find any lagging regarding to the internet connections or my voice is not clearly audible to you, so please let me know. Okay, don't hesitate to say that I am not audible to you. Okay, got it, all of you?
Yes, sir.
Because today's weather is not we can say that weather is not good in Delhi, so there might be an internet problem, so that's why I have to change the connections again. So let's talk about, if I'm saying this is 5 Newton force, okay, this exerting in this direction and the 5 Newton force is exerting in this direction, so the net force on this object will be 0, means the object will not move. The object will not move. Okay, so if I said, just suppose if I, this is a box, this is a box, okay, okay, just ask, if Veer is going to answer this question, if this is a box, a person is exerting a force of 5 Newton to this direction, okay, and another person is exerting a 5 Newton force to this direction, in this direction, in which direction this object will move? Or just imagine, I'm going to give you
Because the force exerted is same.
okay, just give me, this is a 5 Newton force is exerting, this is a rope, okay, and it is being placed like this. This is a 5 Newton force is exerting on this, and 5 Newton force is exerting from this, and here we put a ball. Both of them started exerting the force at the same time. In which direction this ball will move?
In the up direction.
In this direction, the ball will move in this direction.
Yes, sir.
Okay,
Slant.
okay, so this is called the law of parallelogram. Law of parallelogram addition. Okay, we called it law of parallelogram addition. So if we exert a force of 5 Newton in this direction, 5 Newton in this direction, the net resulting force will be in this direction, okay, but in case of current, if I add the 5 ampere current goes to this direction and 5 ampere current goes to this direction, so the net current will be 10 ampere. Okay, that will be not we can say that this will not be yeah, you can say that if I exert a 5 Newton force to this direction, 5 Newton force to this direction, the net resulting force will be 5√2. 5√2 will be the net resulting force, and the object will move with the force of 5√2. That will be the diagonal of this object. Okay, so just imagine if I exert, just I'm going to give you another example. Just listen one more and be concentrative. Okay, don't think that, just listen. Suppose if 5 Newton force is added to this direction and 5 Newton force is added to this direction, 5 Newton force to this direction and 5 Newton force to this direction. Okay, and here is the ball is placed. Just think, at the same time a person hit this ball. Both of the person are going to hit this ball in this direction and this direction. In which direction this ball will move? So this ball will move in this direction. Because both of them are hitting at the same time, a force is exerting on this time and this will. So this force will make this ball to move downward, and this ball will make this force will make this ball to move to this direction. So the net force exerting, the net direction of exerting the force of this object will be this direction, and this will be the exit direction. Okay. But in case of current, if 1 ampere current flows to this direction and 1 ampere current flows to this direction, that the net current will be the net current in the wire. If I add only to this direction, this will be 2 ampere, and this is not going to have any specified direction that the current will move in this direction. No, if the wire is going in this direction, the current will move in this direction. If the wire is moving in this direction, the current will goes 2 ampere current will goes in the direction. But in case of force, the ball will move in this direction only. It cannot move in this direction. It cannot move in this direction. It will move in this direction. So movement of charge is in the wire. If the wire is placed in this direction, the current will move in this direction. But it is simply from positive terminal to negative terminal. From positive terminal to negative terminal. The direction is specified. But what is lagging? That it is not following the rule of law of Pelligram addition. So you have to keep in mind that a vector quantity is that quantity that has direction as well as magnitude and must follow the rule of Pelligram addition. This is important. Current follows the rule of magnitude and direction, but do not follow this rule. And that's why it is not considered as a vector quantity. So do you understood?
Yes, sir.
Sarah, do you understood? And Veer and Huma, do you understood? Or you are having any problem right now? Do you understood, Huma?
Yes, sir.
Let me explain you one more time. Veer, do you understood?
So little bit.
Little bit. Okay. Let me explain you one more time. Okay. Let me explain you one more time. Okay. I'm saying that an object having a physical quantity having magnitude as well as direction are called vector quantity. Okay, vector quantity. Okay, so I'm going to give you an example. Most of the physical quantities are satisfied that are going to have direction and magnitude. But in case of current, let's take me example of current. If I'm saying this is a wire, okay, and this is the electrons, okay, and it is arbitrarily chosen. Arbitrarily chosen means that a group of scientists and other scientists means who are physicists, they set a meeting and they said that we will have the direction of the current will be from positive terminal to negative terminal. They decided, arbitrary chosen, the direction of current is arbitrary chosen, that the current move from positive terminal to negative terminal. Okay, so this is a conductor, and in this current is moving from positive terminal to negative terminal. Okay, so current follows current. If I'm saying 2 ampere current is flowing in a conductor, 2 ampere current, ampere is indicating, just we can say that 2 kg weight, 2 kg mass, or we can say that 25 degrees Celsius temperature. So Celsius is the physical quantity, or we can say that it is a quantity that tells us how hotness means, degree of hotness is told by Celsius. Okay, now just come to the point again. This is 2 ampere current. 2 ampere current is flowing in a conductor, and it is going to have a direction positive terminal to negative terminal. So it is, according to this statement, current is going to have the magnitude, that is 2 ampere, and it is a direction, that is positive terminal to negative terminal. But it is not a current, is not a vector quantity. Vector quantity. Why current is not a vector quantity? Just listen to me. If I'm saying, just imagine you are on a you are playing snooker, okay, snooker, or we can say that pool. Okay, there's a table and this is a table, okay, or there are so many balls. One of the player hit this ball in this direction, okay. So the force exerted by the stick on this ball will allow this ball to move in this direction, okay. Another person came and he hit the ball in this direction, so the ball will move in this direction. But what happened if both of them simultaneously hit this ball with the same force, so according to this, this force will make the ball move in this direction, and this force will make the ball to move in this direction. Since both the forces are exerting simultaneously, so the net movement of the ball will be in this direction. Why? Because of the force, because this force is making this ball downward, so the ball is also moving downward, and this force will make the ball to move in this direction, so the ball will move also moving in this direction. So the net, after some time, the ball will be in this direction, okay. So if both of them hit simultaneously, so the net force will be in this direction, okay. But in case of current, if 2 ampere current, if 2 ampere current is coming in this direction and 2 ampere current is coming in this direction, so the current will not move in this direction. Current moves only from positive terminal to negative terminal. It is not going to move in this direction, okay. Moreover, if the same force is exerting, just listen to me. Have you cleared this, why I have taught you? Are you getting my point?
Yes.
Or still having some problem? Do you understood, Sarah?
Yes, sir.
And Huma, do you understood?
Yes, sir.
And Veer, do you understood now?
Yes, sir.
Okay, so the physical quantities are those physical. So just take me one more example, okay. Just take let me take one more example. If a car moves, let's take in one more examples for you, okay. Just take if a car, this is a car, okay. Let me draw a car. If this is a car, okay, it moves 5 meter in this direction, 5 meter per second, with a speed of 5 meter per second, okay, in this direction, okay. And then it moves 5 meter per second in this direction. So this is its speed. This is speed, okay. If I ask you what is its velocity, what is its velocity? So velocity will be calculated in this direction, because velocity is going to have, means the car is moving 5 meter in this direction, 5 meter in this direction, the net velocity is in this direction. The car is moving in this direction actually, okay. So that will be 5√2 meter per second, okay. So just simply we have to calculate this one. We have to calculate this one is the net direction of the velocity. This is the direction of the velocity. If the car is moving 5 meter in this direction, 5 meter in this direction, 5 meter per second in this direction, then its velocity will be this one. Again, let me take one more example. If I'm saying car cover a distance of 10 kilometer in this direction, okay, and another 10 kilometer in this direction, another 10 kilometer in this direction, okay. Now tell me, Huma and Sarah, what is the displacement? What is the displacement?
It's 10 √2 kilometers square.
10 root 2 kilometer. And will it be in this direction?
Yes, sir.
Okay, so it is going to have 10 root 2, and in the direction, if it is, this will be the 45 degree. Okay, if it is suppose if it is east, okay, and it is south, sorry, it is north. Okay, so it is north, so that the direction will be northeast. Yeah, we can say that this one is the direction will be northeast direction. Okay, northeast direction. This one is the northeast direction. So the distance will be 10 root, sorry, displacement will be 10 root 2, 10 root 2, and in the direction, in which direction? It is in the direction northeast direction. So this is a vector quantity, But in case of current, if 2 ampere current flows in this direction, 2 ampere current flows in this direction, and 2 ampere current flows in this direction. Okay, so the net current will be 4 ampere. Okay, 4 ampere. It is not 2 root 2. Since the current do not follow the law of vector addition, and the direction will be the same in this direction, not this direction. Okay, so actually the current do not follow the law of Pelligram addition. That's why it is not a scalar, sorry, vector quantity. So simply we have to write the difference between the scalar and the vector quantity. So we are writing. Okay, so me write it, scalar and vector quantity. Scalar.
So till when will you take the class, sir? I'm just asking.
Oh, it's 10 minutes over. Okay, no, if you are interested in studying, I will be continuously teaching you to, don't mind. Do you have some piece of work, or you need to go on to bed? Okay,
So I should have dinner and I should sleep, sir.
Okay, but wait a minute. Okay, let me write it. Okay, vector quantity. Okay, so what is scalar quantity? Actually, scalar quantity has only magnitude. Examples, we can write it temperature. Okay, like we can write it temperature, mass, or we can say that there are so many quantities that we can say that time, speed, distance. Okay, and what is vector quantity? Has magnitude as well as direction, okay, and also follows the law of Pelligram vector addition. Okay, this is Pelligram. The short write, we write Pelligram like this one. Okay, so do you understood, Huma, Sara, and others? Veer, do you understood?
Yes, sir.
Do you have any doubt right now? Do you have any doubt? No, I thought that we will be going to discuss all these questions, but actually the time is over. So don't worry, we will discuss it some other day. The topic is what we studied. Let me quickly revise it. Okay, so today we did these questions, and you know very well here is one thing in this question. we learned that distance can't be, sorry, displacement can't be greater than distance. Okay, so we learned this one, distance can't be, displacement can't be greater than the distance. So we should keep in mind. Next, distance and displacement differences. And after this one, we did this question that we are very much familiar, and you all have done this one correctly. And in these questions, Sara did well. Okay, next we discuss the scalar quantity and the vector quantity. So those physical quantities that are going to have only direction as only magnitude but not specified directions are called scalar quantity. And those quantities that are going to have magnitude, direction, as well as must follow the law of Pelligram addition. Law of Pelligram addition that are considered to be as vector quantity. If there are so many quantities that has direction, okay, as well as magnitude, like we can take the example of pressure also. Pressure, if we are, I'm saying that the balloon, okay, this is a balloon, okay, just imagine this is a balloon, okay. So the air pressure will be always exerted perpendicular to the surface. Direct pressure is going to exert always perpendicular to the surface, but similarly it is exerting in all directions. There is no specified direction, so pressure is also not considered as vector quantity. Okay, so it is simple that vector quantity should have magnitude plus direction plus follow law of Pelligram addition. Okay, similarly explain you about this one. So some of the examples, then I explain you about the current. The current is going to have the direction as well as magnitude, but not follow, since it does not follow the law of Pelligram addition, it is not considered as vector quantity. Next one is, so this is your homework. I'm going to give you some examples. These are the graphs, okay, and there are some questions, 2 or 3 questions I'm going to give you. So you have to perform this. You have to do this one in the homework, and then we will discuss in the next class. Okay, so for today, thank you so much for joining this class. Okay, should I leave?
Thank you, sir.
Okay, Homa and Sarah, do you understood the topic today I teach you?
Yes, sir.
Okay.